This material summarizes key points on hovering. What is the aim of hovering? The aim of hovering is to hold a steady position over the ground within a defined tolerance. In ground effect, treat the collective as a height controller. Very small changes, then wait for the aircraft to respond. Think of cyclic as position controller, pedals as heading controller, collective as height controller, and governor throttle as rotor RPM guardian. In wind, accept that the helicopter wants to move. Your job is to nudge it back, not to hold it rigid. Now we need to deal with what we will call visual strategy. Firstly, where to look. Don't hover over a featureless field if you can avoid it. There's almost no movement information and learning is slow and frustrating. For a 3-5 feet hover, pick visual cues 30-50 feet in front of the helicopter. Further away equals too little feedback. Too close equals too much feedback and over-controlling. When looking, make sure you use 2 references. One directly ahead for lateral drift. One slightly off to the side for fore-aft movement. Next, consider vertical cues. Use vertical objects to judge height and subtle movement by watching how their edges move relative to the background. Over uniform surfaces, consciously choose something cone, marker, sign, to create vertical reference. The key habits to focus on include 1. Keep your eyes mostly outside, scanning between your 2 main references and the horizon. Only short instrument flicks to RPM and EPM. And 2. Avoid staring at the ground under the nose or out the side. That invites over-control and disorientation. Next, let's consider control strategy in the hover. The clean model is cyclic primary, controls position and ground speed. Lateral cyclic moves you left or right of your position over your line. Longitudinal cyclic moves you forward or back along your line. Treat your collective as a height knob when in ground effect, small change, then back to neutral pressure. OGE or with significant wind, collective sets rate of climb descent. To return to a stable hover, you'll usually return near the previous setting. Pedals are purely for heading, not for track or drift. Big pedal movements will translate into roll and/or pitch. Anticipate with light cyclic. Note that the helicopter responds with a lag, especially in pitch. Over-controlling comes from adding a second input before the first has taken effect. The trick is small input, then back to neutral, then wait. Expect the response a beat later. Then trim with very small follow-up inputs. 4. Standard Cabri hover technique. In a Cabri, your entry to hover from liftoff is as follows. 1. Pick your cues. 2. Ground refs 10-15 meters ahead. Clear area. Wind noted. 2. Smooth collective raise through to light on skids. Guard the RPM and torque. Coordinate pedals to keep nose straight. 3. As you pass light on skids, stabilize at 1 to 1.5 meters height. Tiny collective trims. Cyclic to freeze drift at your references. Pedals to hold heading. Now to the art of holding the hover scan pattern. A head reference, side reference about 2 or 10 o'clock to judge fore, aft, horizon. Then quick check of RPM EPM torque, then back out. Corrections. Drift left or right, respond with tiny lateral cyclic, then neutral. Drift forward back, tiny longitudinal cyclic, then neutral. Climb descend 1-2 mm collective, then neutral and retrim pedals. Expect to work hardest into wind and with quartering winds, especially right rear in the Cabri. Now leaving the hover is called the transition for low-speed departure. Keep collective approximately constant and allow the aircraft to accelerate. Use cyclic to control height in the first few knots where power required drops quickly, then retrim collective as needed. Stay inside the Cabri height, velocity diagram, and performance limitations. There are hover training drills one should treat as core progressions and keep cycling through. 1. Partial control drills using one control at a time. Cyclic only to move between 2 marked spots. Collective only to climb and descend between 2 known heights. Pedals only to turn to nominated headings. 2. Taxi along a line. Hover taxi along a runway edge centerline. Nose pointing along the line, keeping the line passing between the pedals. Vary wind direction. The lesson is, lateral cyclic equals drift, longitudinal cyclic equals ground speed, pedals equals heading. Progression. Move a few meters left-right of the line, stop, stabilize, then back. 3. Height change drill in the hover hold position over a fixed point and climb from 3-4 feet to 10 feet and back, keeping heading and position constant. 4. Turns in the hover. Maintain height and position while turning to nominated objects around the horizon, in both directions, stopping precisely on each. Aim for smooth start-stop, minimal drift. 5. Hovering with different winds, practice at all 4 cardinal wind directions and at higher but still legal wind strengths to understand pedal workload, crosswind behavior, and when to simply say no. 6. Moving around short hops from this sign to that sign, 2 meters behind, facing down the road. Short, precise moves, frequent stabilization. Include sideways and backward moves, with explicit stopping points to build judgment, especially when backing. Note in the Cabri there are specific hazards which are not so much in the flight manual as in the service letters. Firstly, your controllability at low rotor RPM. Cabri's main rotor will still generate lift at rotor speeds well below nominal, unlike many light helicopters, which makes it possible to still be airborne with dangerously low RPM and reduced tail rotor authority. Tail rotor thrust falls as RPM falls. Combined with lift still being available, this can lead to sudden loss of your control in hover low speed. Implication for hovering. Treat the green RPM band as absolutely non-negotiable. If RPM decays, lower collective first and stabilize RPM before worrying about position. Secondly, the fenestran and vertical fin behavior. The Cabri shrouded tail rotor and large left-angled fin give strong yaw stability in forward flight and good thrust, and are immune to LTE vortex ring tail rotor stall in testing. However, high pedal inputs can produce very high yaw rates, which are disorienting and dangerous near the ground. Avoid pedal-to-the-floor spins in the hover, and especially during late approach. Thirdly, governor and throttle position sensor. Throttle sensor issues can degrade governor behavior and raise workload. The flight manual procedure relies on the pilot being able to override the governor with the twist grip at any time. Guard RPM visually and orally. If governor misbehaves, follow the engine governor failure procedure and prioritize RPM control over precise hover. Fourthly, extreme maneuvers. Cabri's strong envelope and forgiving behavior can lead to overconfidence. Once you step beyond flight manual margins, the extra safety margin disappears. 4. Hovering. Avoid aggressive low-level maneuvers, low G, steep nose down, or quick stops near ground. Finally, cockpit mounts are a problem. Avoid suction or bonded mounts on the windscreen or controls vicinity. They can damage plexiglass and interfere with controls if they fail. For hover training, you want 0 extra snag points that could catch clothing or harness when you're busy. Remember, the Cabri flight manual is your primary operating document. It must be kept current and used together with applicable regulations. Service letters are supplements, not replacements. They highlight specific risks and should be read as amplifiers to the AFM, especially for training and approach hover work. Now to some checklists. Micro pre-hover, and if it starts to go wrong. Checklists before hover. Check area, wind, and mindset as follows. Area, obstacles, wires, dust, slope, people. Wind, direction, strength, gusts. Where is your escape path? Performance, weight and DA within height chart, margin to limits. References, 2 ground vertical cues 30, 50 feet ahead. Mindset, small inputs, anticipate lag, RPM, and your risk should be top of mind. If it starts to go wrong. 1. Rotor RPM, check and correct first. 2. Height, stabilize 1 to 1.5 meters if possible. Accept some lateral drift rather than force it. 3. Yaw, avoid large pedal stabs. If your rate increases near ground, lower collective, level the machine, and prioritize stopping rotation. 4. Position, only once RPM, height, and you're under control. Do you refine your spot again? Some final thoughts. Be conscious of how your tail rotor works. The tail rotor blows air out to starboard. Right pedal increases blow, left pedal reduces blow. As nose goes right, need to reduce blow, so left pedal as nose goes left, then right pedal to increase blow. Remember to turn right whenever possible. This is a feature of torque reaction. When you turn right, you increase tail rotor thrust, more airflow through the tail rotor, more control authority. Your rate is smoother, easier to arrest when turning left. You reduce tail rotor thrust, less airflow over the tail rotor, less control authority. Your accelerates even faster, harder to arrest, and last of all, the yaw string. At any speed the yaw string tells you am I coordinated. In a stable, no drift hover, the yaw string tells you from which direction is the wind actually coming.